Welcome, ladies and gentlemen. So what I'd like to do is show you how to factor this expression when we have a to the sixth plus 12a to the fourth plus a squared. Now, before we go and do this, we want to make sure, can we factor out any common terms, right? Is there anything else I can divide out? Now, remember, when you're factoring, you're pretty much like dividing them out, right? So I noticed these all share an a, and the highest power that I can factor out would be a squared. So if I factor out a squared, I'll just be left with 36 a to the what? Well, again, 36 divided by a, 36a to the 6 divided by a squared. What happens when we divide exponents? What we're simply doing is subtracting the exponents. So we have 36a to the fourth, right? So there we go, ladies. So when you're factoring out that a squared, you're basically subtracting. So it'd be a to the fourth plus 12a squared plus 1. OK, so I still need to go ahead and look into factoring this, right? But at least I factor out an a squared. Now we want to do is determine, can I still factor this out further? So we look at our basic definition of a quadratic, ax squared plus bx plus c. All right. Now, I know this is a little bit confusing because you say, well, a's here, now a's has this power, right? Well, a represents the coefficient of my x squared. And that might even be more confusing because you say, well, we don't have x squared. We have a to the fourth. Well, for right now, forget about the a to the fourth, or even if it was x to the fourth, right? A represents the coefficient of your largest, of your leading coefficient, right? So that'd be my 36. C would represent your constant, and B would represent the coefficient of your middle term. This is for all quadratics. I know it's confusing with a to the fourth and not x squared, but just kind of follow me with this. So to factor this, I need to multiply a times c and determine what two numbers multiply to give me a times c, but then add to give me b. Well, a times c would be 36 times 1, which is just 36, but then add to give me 12. OK, so to do that, I need to look at the factors of positive 36. Now notice these factors of 36 are both positive, and they have to add to give me a positive 12. Therefore, the factors both have to be positive. So when I write out the factors of 36, I have 36 times positive 1. I could do 18 times 2. I could do 12 times 3. I could do 9 times 4. And I could do 6 times 6. Now, the only one of these factors, all these factors obviously are factors of 36 because they multiply to give you 36. But the only one of these that add up to give me 12 are positive 6 and positive 6, right? All right, so now kind of gets into our confusing part of this problem. Basically, when we had like a was equal to 1, you could just take those factors and say, oh, well, then it's a plus 6 times a plus 6, right? When there was no coefficient there, you'd take those factors and write them in there. But we have a problem. A times a does not give us 36a to the fourth, and 6 times 6 does not give us 1. So our variable, our factors, need to be a part of 6a. All right. Now, what two terms are the only two that add up to give me 1? Well, obviously, that's going to be 1 and 1, right? The next thing that I'm having trouble with, though, is, again, 6a times 6a is 6a squared. I need to get this to be 6a to the fourth. And again, they have to be the same. So remember, when we're looking into multiply, we already factor out a squared, right? But remember, when we add these, 6a times 1 plus 6a times 1 is going to be 12a. We need them to be a squared. So therefore, all right, this is 6a squared and 6a squared. Now, 6a squared times 1 plus 1 times 6a squared is 12a squared. 6a squared times 6a squared is 12a to the 2 plus 2. I'm sorry, that's 36. Wow. A to the fourth. So therefore, and then you have your a squared, which you bring down. So there you go, ladies and gentlemen. That is how you factor your trinomial. Thanks.